Hello everyone, and welcome to this short Comsof Fiber demo. My name is Jonas. I am the Comsof Fiber product manager here at Comsof. Our software, Comsof Fiber, both speeds up the network design process and optimizes the network design, making network deployments cheaper. Comsof is located in Ghent in Belgium and in Toronto, Canada. We've been around for over 20 years, and the software is being used in projects all around the world. Today, I will cover the main challenges planners and designs face. You will learn how automation can tackle these issues, and I will show you the Comsof Fiber software and how it helps our clients. Still today, a lot of planners and designers use manual processes to come up with fiber network designs using AutoCAD and Excel. This is a very time-consuming process, definitely if you want to design networks of over 1,000 homes. It's not only time-consuming, but it's also error-prone. And these errors can be very costly. You can either have to restart the design, or if the error is only discovered during the deployment phase, for example, if a cable is missing, then it will be very costly to correct that error. Network designs also become more and more complex. If you want to integrate existing infrastructure like existing cables and ducts in your network plan and come up with a custom optimized design, or if you want to design converged networks connecting fiber to both antenna locations and homes at the same time. That's why Comsof Fiber exists, to help and assist planners and designers to come up with cost-optimized designs in an automated way. When designing a fiber network, you need to decide which equipment you need and where you want to locate it. You need to decide which type of cabinet you want to place, which cables and ducts you need to connect all of the homes, and how you want to route these cables in the most cost-effective way. You need to make sure that every building or antenna location in your area is covered using a fiber connection and that everything is connected back to a central office. Now, I'm going to show you how you can do that using Comsof Fiber. Here, I have an area loaded up in the software. As you can see, there's a lot of buildings here that require a fiber connection. If I take a look, each building tells me how much homes there are and how many fibers need to be connected to it. Now, what the software will do, it will decide, like explained in the presentation, it will decide how to route all of the cables and connect these back to my cabinet locations. Let me just show that here. So what you see is every area of homes is clustered up and connected to an aggregation location, distribution point, as this is called in our software. And the software plans all of the cables to connect back to this aggregation point. So you can see here, this is a 2-fiber cable that's connected to this building. And it also plans the ducts where the cables go inside. Here we see we have a 12-way microduct bundle that is placed on this route to contain all of these cables. The software will do this in an automatic way all the way back to our central office location, which is located here. So it plans all of the cables to connect all of these aggregation points using a feeder cable. Next to the network design, it also comes up with a very detailed bill of material, which you can see right here. In the bill of material, we give an overview of all of the costs needed for doing this network design. You also get some high-level cost overview showing, for example, the deployment cost per home passed or the activation costs. But most interesting is the breakdown of costs per type of equipment. What you can see here is the total amount of trenching that is needed. Also, the amount of cabinets that we need to place to connect all of the homes, and a breakdown of all of the ducts that is needed and cables that are needed. This is done for every layer of the network according to the network design that you saw earlier. This is very valuable information and saves a lot of time when doing a network design. A fiber project is very costly. The main cost factor are the civil works, all of the trenching that is needed to place the cables, to place the ducts and connect the homes. Now, a way to reduce that deployment cost is to reuse any existing infrastructure that is available in the area that you're designing. Any ducts or cables that can be reused will reduce the cost of the network significantly. Of course, this adds to the complexity of the design, making it a lot harder for the network planner. But Comsof Fiber is able to handle that easily and come up with a cost-effective solution. Let me show you how this is done in the software. Right here, you see the same area that I covered in the first demo. The difference is that we have an existing pipe here, so an existing duct that we can reuse in our network design. This is the light blue line that you see right here. Now, what the software will do is it will take into account the cost of using that existing duct, compare it with the cost of trenching, but also the cost of entering and exiting that duct, because each time you need to do that, of course, a manhole needs to be placed and you need to connect to it. So all of those costs will be taken into account to come up with the network design. Now, the result of this is shown right here. So what you see right here is we have our feeder cable that enters the pipe here, and then it will exit here. So this piece of existing pipe will not be used because it's not cost effective. Now, coming up with cost effective design is the goal, but you need to make sure that your design is buildable. You need to make sure that any field constraints are also taken into account for the design. For example, one of the things that you might need to do is change a route of a cable. For example, here at this junction, based on field information, we might want to use the other side of the junction to route our feeder cable. Now, using the software, it's very easy to do so and make this change. So we just delete part of the route, add a new piece, save that, and then we recalculate the network design. Now, calculation has finished, and what we see is that this change of route that we have drawn is now used for routing the cables. So, and not only the cable is rerouted, we have our new cable here, but also the duct where it is in will be rerouted and the bill of material will be adjusted. The goal is to come up with a cost-effective design which is buildable. Of course, you need to make sure that you follow the design guidelines set up by the operator. And the architectural rules for every operator can be different. This makes it very complex, definitely if, as a designer, you are creating designs for different operators. Also, if you're changing the design based on field survey inputs, for example, changing cabinet location or reassigning homes, it's easy to break the rules set out in the design guidelines. And that's why with Comsof Fiber, we make sure that you can configure the rule set according to the design guidelines and reuse that for every single project that you do, making sure that all the designs are consistently following those rules. Also, when you're making changes to the design, there's an automatic check to make sure that no architectural rules are being broken. Our design rules are created based on all of the projects that we did and are doing around the world. let me just show you some of the settings that you can configure in the rules. One of the things that you can configure in the rules are the splitter settings. So if you're doing a POM design, you need to configure which splitters you want to use and where you want to place them. For example, in this case, we have a centralized splitter architecture with a 1:32 splitter in the distribution point or distribution cabinet. But we also have some settings for larger buildings. So in case of more than 11 homes inside of a building, then we use a cascaded split where we have a 1:4 splitter in the building connected to a 1:8 splitter in the distribution point, resulting into an end-to-end split ratio of 32. So this is highly configurable according to the architectural rules of the operator. What is also important that can be configured is the cost of the civil works. So this is shown here. So here you can configure the cost of trenching, of reusing existing pipes. And these costs are taken into account when doing the routing. Make sure that you come up with a cost-effective design. Some other rule settings are, for example, the capacity of a distribution point. So in this case, we want to connect 64 fibers up to a distribution cabinet. And this is the equipment that we want to use in the distribution layer. So we want to use 12-way, 24-way, and 36-way ducts. So all of these are available, each with their own cost, and the software can choose which ones it wants to use for the network design. These were the main features that I wanted to show you today. Of course, the software also has some other capabilities. It's also can also be used to plan converged fiber to the home, fiber to the antenna, or fiber to the business designs. We also support phased rollouts. If you want to roll out your design in multiple phases over multiple years, the software can determine which equipment needs to be placed in which year. You can also do optical budget calculations, and if you want to do include redundancy in your design using rings, this is also supported. Thank you for watching, and if you want more information, please don't hesitate to contact us at info@comsof.com or visit our virtual booth. Have a nice day and stay safe. Bye.